Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces you can actually understand.
Today we're looking at something that affects anyone who has ever interacted with an AI, which is basically everyone at this point. We all assume that these big, powerful language models are super geniuses, right?
Right, you ask it a question, it gives you a brilliant answer. But what if you ask it a slightly different question? What if you make a typo? Or what if you ask it to give you the answer as a bulleted list instead of a paragraph?
Exactly. Does it still give you the same brilliant answer, or does it get confused and give you something completely different? That's the core question of a new paper from researchers at ServiceNow titled Evaluating Robustness of Large Language Models in Enterprise Applications.
Okay, robustness is the key word there. In plain English, what does that mean in the context of an AI?
Think of it as the AI's ability to roll with the punches. If an AI is robust, it means small, unimportant changes to the instructions you give it won't cause a massive change in the quality of its answer.
And this is super important for businesses, or what the paper calls enterprise applications. If you're a company using an AI for, say, customer support, you need it to be reliable. You can't have it failing because a customer in Germany asks a question in German, or because another customer accidentally adds an extra space in their query.
Absolutely. So these researchers decided to put it to the test. They basically designed an obstacle course for 11 different large language models to see how robust they really are.
An AI obstacle course. I love it. What were the obstacles?
They called them perturbations, which is just a fancy word for small changes or disturbances. They came up with a few different kinds. First, there were general perturbations.
Let me guess, things like spelling mistakes, extra punctuation, or typing in all caps?
You got it. All the messy ways real humans actually type. Then they tested positional perturbations. This is where they changed the order of the instructions. So instead of saying, summarize this customer support ticket and then list the key events, they might say, list the key events from this ticket and then give a summary.
That seems like it shouldn't make a difference. It's the same information, just in a different order.
You would think. They also tested format perturbations. This meant asking for the output in different ways. For example, asking for the answer in plain text versus a structured format like JSON, which is a way of organizing data that's easy for other computer programs to read.
And the last one, based on your earlier example, must be about language, right?
Exactly. They tested multilingual and cross-lingual changes. So they'd give the AI a task in Spanish and ask for an answer in Spanish. Or they'd give it text in French and ask for an answer in English. All things that happen constantly in global businesses.
So they ran all these AIs through this gauntlet of typos, reordered instructions, and language swaps. What did they find? What's the big headline?
The big headline, and this is the most surprising part, is that bigger is not always better.
Whoa, okay, because the common wisdom is that the models with more parameters, the bigger the brain, so to speak, are always the smartest and most capable.
That's what we all assume. But this paper found that an 8 billion parameter model, which is pretty small these days, actually outperformed most of the much larger models, including one with over 120 billion parameters.
That's a huge difference. It's like a go-kart outperforming a monster truck in an obstacle course.
It is, and to make it even more interesting, another model that was also 8 billion parameters performed the worst out of all 11 models they tested. The gap in performance between these two same-sized models was massive.
So what does that tell us?
It tells us that the size of the model isn't the most important factor. The way the model is built, its architecture, and the data it's trained on can matter a lot more than just its raw size. Quality over quantity.
That's a huge finding. So what were the things that tripped up the AIs the most? Where did they stumble?
They found that the models were least robust when dealing with different languages and when the order of the instructions was changed. Those positional perturbations we talked about. They caused a huge drop in performance. The simple things like typos and extra white space were much easier for the models to handle. But here's another fascinating detail. They found that some models had a very specific Achilles heel.
An Achilles heel? Like what?
Well, one model that was ranked third best overall was fantastic at almost everything, but it completely failed when asked to generate output in a specific format called YAML. It just couldn't do it. Another model completely bombed when it had to use a format called XML.
So a model can be a genius in general, but have a really specific, weird blind spot. That's wild. It means you can't just trust the overall rankings.
Precisely. The researchers also found that Japanese was a particularly challenging language for most of the models to handle robustly. The quality of the output tended to drop more when the task was in Japanese compared to, say, Spanish or French.
So what's the big takeaway for all of us, and especially for the companies that are relying on these AIs?
The takeaway is that you can't just pick the biggest, most famous AI model off the shelf and assume it's going to be perfect for your needs. Even tiny, seemingly harmless changes in a prompt can cause performance to drop by up to 40 percentage points, which is enormous.
It's basically a try it before you buy warning. You have to test these models in real-world conditions with the messy inputs and specific formats you're actually going to use.
Exactly. This research provides a roadmap for how to do that testing. It shows that robustness is a critical factor we need to pay attention to, and the relationship between a model's size and its actual performance is a lot more nuanced than we thought. It's not about how big the AI is, but how well it's built for the job.
A fantastic reminder that in the world of AI, the devil is truly in the details. That's all the time we have for today. Thanks for tuning in to Daily Papers.